Welcome to Grablo. In this tutorial, we'll combine camera vision and AI analysis to create a face-tracking servo motor system that follows your face like a pair of robotic eyes. Let's get started. Create a new project and add a new logic. First, let's create a control to start the camera and detect faces. Since the camera only needs to start once when the project begins, add a once type condition. Next, add an AI camera action. Click Select and create a new camera. Grablo supports up to 8 cameras simultaneously, identified by index numbers from 0 to 7. If you have just one camera connected, simply enter 0. Grablo works with most cameras, from Raspberry Pi cameras to USB cameras. Select the resolution and set the orientation. Since camera views are normally non-mirrored and can be confusing, select Horizontal Flip so it mirrors your movements naturally. Select the camera we just created and click the Add button in AI Analysis to add our AI processing. First things first, we need to know if there's a face in the frame at all, right? Set Analysis Type to Face Detection and Command to Face Detected. Create a variable to store whether a face is detected and assign it. Next, let's add another AI analysis to read the x-coordinate of the detected face's center point. Again, select Face Detection and set the command to Get Face. Since there might be multiple faces, set Select By to Largest Size to track only the face occupying the largest area on screen. Create a new variable for the center point's x-coordinate and assign it. Perfect! Now while the camera is running, whether a face exists and the face's center x-axis coordinate are continuously stored in our assigned variables. Now let's create the control that actually rotates the servo motors based on the face coordinates. We only want to move the servos when a face is detected, so add a compare condition and select the face detected variable. Set the operator to equal and value to true. Now let's calculate how much the servos should rotate based on the face's x-axis coordinate. Add a set variable action and create a new variable called servo angle. Launch the block editor to enter the value. We need to convert the face's x-axis coordinate linearly to a servo motor angle. From the Math category, drag a linear scale block and connect it to the return block. Connect the face x-coordinate variable to the input, then configure it so when the x-coordinate changes from 0 to 640, the servo angle ranges from 45 to 135 degrees. Of course, these values will vary depending on your camera resolution and field of view, so test and adjust them accordingly. Time to rotate those servos. Add an I/O device control action and click Select. Search for servo. Since we're using a Raspberry Pi as our controller in this tutorial, select the Raspberry Pi servo motor library. Enter the GPIO pin number where your servo is connected. Duplicate this servo to add a second one. Change the name and enter the GPIO pin number for the second servo motor. Select the first servo motor and set the command to Set Position. Click the block editor to enter the position value. Select the servo angle variable from the variable read block and connect it to the return block. This rotates the servo to our calculated angle. Duplicate this block to create the control for the second servo motor. Click Select to choose the second servo motor. The command and angle are the same, so leave them as is. Great! Our logic is complete. Let's review what we've built. When the project starts, we initialize the camera and continuously store face detection status and the face's x-axis coordinate through AI analysis. When a face is detected, we calculate the servo rotation angle based on the face's x-coordinate and rotate both servo motors accordingly. Simple, right? Now let's create a dashboard for monitoring. First, add a camera widget to view the camera feed. Select your camera and adjust the size appropriately. Also add widgets for face detection status, face X coordinate, and calculated servo motor angle. Before running the project, connect your camera and servo motors to the Raspberry Pi, as shown in the connection table. You can use a Raspberry Pi camera or a USB camera. Both work perfectly. Note that in this tutorial, we're powering the servos directly from the Raspberry Pi's 5-volt supply. While this works for testing, we recommend using a separate 5 volts DC power supply for actual use. Once everything's connected, connect to your controller and run the project. When a face is detected, the servo motors rotate according to the face coordinates, making it look like a pair of eyes following your face. Pretty cool, right? If your servo motors shake or jitter while rotating, that's actually quite normal. It happens because the servos react to even tiny changes in the face's X coordinate. To prevent this, we need a filter for smooth rotation. First, let's add a variable for our filter. Go to Project Settings and add a new variable called Previous Servo Angle. Now add a custom action below the servo angle calculation block. Select the servo angle variable from the variable read block and multiply it by 0.5. Also multiply the previous servo angle variable by 0.5. Add these two values together and assign the result back to servo angle. Finally, set previous servo angle to the current servo angle value. This creates an average between the current and previous angles. In every frame, when a new servo angle is calculated, we blend it 50-50 with the previous angle. This way, even if the face coordinate changes suddenly, the servo only moves halfway there, keeping the other half of its previous position. The result? Instead of jerky movements, the servo smoothly and gradually moves toward the target position, dramatically reducing the shaking. You might notice a slight delay in response, but you'll get stable, smooth motion in return. Congratulations! You've successfully built your Grablo project. Ready to explore more? Check the links for tutorials and support. Thanks for watching and enjoy creating with Grablo.